a situation. It says the distance traveled by a high-speed train is proportional to the number of hours traveled. So they're showing us a direct variation still. It says interpret each plotted point. So notice that the plotted points are the dots that they have on here, 0, 0, 1, 200, and 4, 800. Those are what we have listed here. And they want us to interpret what each of those means. So if we can interpret one of them, then we can understand the rest of them. So I never pick 0, 0 to help me interpret because it doesn't tell me a whole lot. So I'm going to pick one of the other ones. I'll go ahead and do the 4, 800. So in order to understand what that means, I'm going to follow my lines to see what my 4 in this case is hours. So our 800 is our distance in kilometers. So here we could travel for 4 hours, would take us 800 kilometers. Or you could say I traveled 800 kilometers in 4 hours. However you would like to go ahead and understand that. So then this next one is the same concept. Our 1 is representing our hours, so 1 hour. I could travel 200 kilometers. And then my 0, 0, well, would be at 0 hours. I would travel 0 kilometers. So that's interpreting what each of those plotted points means. The next question says, what is the speed of the train in miles per hour? So I'm going to pick any of those sets of coordinates other than 0, 0, because obviously 0, 0 is going to say 0 miles per kilometer. So this should have been actually, what is the speed of the train in kilometers? It's a typo, kilometers per hour. So we're going to go ahead and figure out our kilometers per hour. So kilometers, I'll just pick this one. So my kilometers was 800. Per my hours was 4. And if I reduce that down, it becomes 200, or 800 divided by 4 is 200 kilometers per hour. Now, if they really did want us to change that into miles per hour, we could jump back into what we did back in lesson, I think it was lesson 5 or 6, where we worked with conversions. So our conversion, I'm going to set it up as a ratio and not worry about the fact that it is a rate. I want to convert 200 kilometers into hours. So our conversion, pull my book out here really quick out of the back of my book. 1 kilometer is 0.6 miles. So 1 kilometer is 0.6 miles. So now I could set that up as a proportion, cross multiply. So 0.6 times 200. And then divided by 1 is still 120. So really this is 120 miles per hour. So either of these would work. But if they did specifically ask for miles per hour, we would have to do that next step. So here it says, how far could the train go in 11 hours? So we're just going to go, how many kilometers could it go in 11 hours? So you can really use any of your original rates if you wanted to, or you could use your reduced rate of 200 kilometers per 1 hour. So 200 kilometers you could go in 1 hour. How far could you go in 11 hours? And I know some of you can just go through and say, well, I know I'm going to multiply 11 times 200. So 200 times 11 is going to give me 2,200 kilometers. So that's how far we could go in 11 hours. If I wanted to figure out what that was in miles, well, I do 0.6 times that. It'd be 1,320 miles. So that's quite a ways in 11 hours. Okay, so that's working with interpreting information off of a graph, and we did work with graphs a little bit in our previous lesson. Okay, so let's try another one. Oops. Get rid of these. Sorry. I'm going to get rid of these lines. Okay, so here's our next information. It says interpret each plotted point in the graph of the proportional relationship. So we have money here, and they want us to interpret each point. So I'm going to go ahead and do my points of 0, 0, 1 comma 15, and 4 comma 60. So we're going to go ahead and interpret what each of those means. So I'm going to start with the 460. So my 4 was hours worked, and my 60 was dollars that I made. So 4 hours equals $60. And you can rewrite that. I made $60 in 4 hours, however you want to write it out, just so that you're understanding what the 4 and the 60 mean. So then here, 1 hour equals $15. And obviously, if I work for 0 hours, I'm going to get $0. Okay, so now what is the rate? So if you ever have one where they've got the rate where the you've got 1 in your X, well, that is your rate. You're going to get $15 per hour, or you can take any of these and set them up as the rate in dollars per hour. So I could take 60 over 4 for my dollars per hour, which is still going to give me that $15 per hour. If you were to work for 10 hours, what would your earnings be? So notice that on the graph, I don't have 10 hours. So I'm going to have to either use a proportion or use my unit rate. So if I'm going to get $15 for 1 hour, or I could use the 60 over 4, how much would I get for 10 hours? So this is very visual. I know some of you don't need that proportion, but some of you do. So then 10 times 15 would give me $150. Okay. Okay, so let's go ahead and look at one more here. Oh, love it when things fall apart there. So let's look at this one. Okay, oh, let's keep bouncing out. Okay, so here I've got a hot air balloon. So my points are 0, 0, and 1 comma 5, and 6 comma 30. And let's see, I like to always use the one that's furthest out just because there's most space. So my 6 is seconds, and my 30 is feet. So here at 6 seconds, I'm 30 feet high. Okay, so then that means here at 1 second, I am 5 feet high. Oops, when I spelled height, I'm not even spelling it right. And then here, this would be 0 seconds, would be 0 feet high. So I'm on the ground. Okay, so now what is the rate? So my rate, I'm just going to pull from right here. My rate is 5 feet per second. And I know that's reversing it. Remember, rate is always your slope or your rise over your run. So that's where you're putting your y over your x. What would the height of the hot air balloon be after 9 seconds? So if I use my 5 feet per 1 second, and we want to know after 9 seconds, matching labels, cross multiply 9 times 5 would give me 45 feet high.